Okay, good. Okay.
Okay. So in question 9, basically the differential equation is given. We want to
Mhm,
find the solution by Laplace transform. So
mhm,
now we take Laplace transform of both sides of equation 1. So taking Laplace on both sides of equation 1, we get Laplace of y double prime plus 4y equal to Laplace of delta into t minus pi. Now we will apply the linearity theorem of Laplace transform. So Laplace of y double prime plus 4 into Laplace of y is equal to, we know that Laplace of delta of t minus a is equal to e power minus as. But here you can see that at the place of a, this is pi, so this will become e power minus pi s. Now we know that the Laplace of y double prime is s square y of s minus s y of 0 minus y prime of 0 plus 4 into Laplace of y is y of s. This is equal to e power minus pi s. Now we use the initial condition y of 0 equal to 0, y prime of 0 equal to 0. So when we put here, this will become minus s into 0 minus 0, because this is the values of these are 0. So and here you can see that s square plus 4 into y of s. We take y of s common from this, so we get equal to e power minus 5s. In next step, you can see that when we simplify this, we get s square plus 4 into y of s is equal to e power minus 5s. In next step, you can see that we divide both sides by s square plus 4, we get y of s is equal to e power minus 5s into 1 over s square plus 4. Now we take inverse transform on both sides. So we get Laplace inverse of y of s is equal to Laplace inverse of e power minus 5s into 1 over s square plus 4. Now when we take Laplace inverse of this, we get y of t is equal to, here you can see that this is a 1 over s square plus 4. And we know that Laplace inverse of 2 divided by s square plus 4 is a sine 2t. So to make here 2, we multiply and divide by 2. So 1 over 2 into Laplace inverse of e power minus 5s 2 divided by s square plus 2 square. You understand this step?
yes, yes.
Okay. Now we use the shifting theorem of Laplace transform. Laplace inverse of e power minus as f of s is equal to f of t minus au of t minus a. So now you can see that when we use this theorem, we get this is a f of Laplace f of s. So this will become f of t minus a. This is f of t sine 2t. So f of, when we replace this by f of t minus a, and the place of a, here you can see that this is a pi. So when we do use this shifting theorem, we get 1 over 2 into sine 2 into t minus pi u of t minus pi. So in next step you can see that, and we u of t minus pi, this one. Okay. So now we expand this sine 2 into t minus pi. You know that sine alpha minus beta formula of trigonometry. So this will become 1 over 2 into sine 2t into cos of 2 pi, because this 2 will be multiplied with both. You understand?
Yeah, yeah.
Okay. Minus cos of 2t into sine of 2 pi u of t minus pi will be the same. So now we know that the cos of 2 pi is 1 and the sine of 2 pi is 0. When we put these values, we get 1 over 2 sine 2t into 1 minus cos of 2t into 0 into u of t minus pi. In next step, you can see that when we simplify this, we get 1 over 2 sine 2t into u of t minus 5, because this will become 0. 0 multiplied by something is a 0. And we know that sine 2t is a 2 sine t cos t. Trigonometric identity formula of sine 2t. 2 sine t cos t. Now when we simplify this 2 and 2 will be cancelled with each other. And at last we get the required solution y of t is equal to sine t cos t u of t minus t, which is the required solution of the above differential equation 1.
Okay, so I believe you forgot